Once again, welcome to the 2018 Northwest Pinball and Arcade Show. I am Doc, and as always, my partner in crime is David Shoemaker. And we would like to welcome in our new Geek Gamer audience. Pleasure to have everybody here. Anybody doesn't know who Geek Gamer is? Well, you better talk to Geek Gamer Chase Nunez. And so, what we're going to cover this afternoon is WPC GI. That is Williams Pinball Company General Illumination. In pinball, there are two main lighting circuits, and that is the general illumination, lamps that are on all the time, and feature lamps. Those are things that...
With an asterisk.
Yes.
They can be computer controlled, so they may be dimmed or turned off, but in general, they are on all the time.
Correct. And the reason that David brought that up is that when they went to WPC, the general illumination lamps are now controlled by triacs. And they did that so that they could kind of make the GI feature lamps and dim things. And it kind of started a lot with the Addams Family.
You can make it, the whole game just goes black. Ooh, what happened? And then it comes up, or effects. They could do cool stuff.
So one of the most common things that we see, and we see quite a bit of it, is that the general illumination in a WPC is burnt up. And the reason that it's burnt up is because since the inception of pinball, general illumination has been overamped until the last few years when they went to LEDs. LEDs in a pinball machine draw 1/8 of the power, and they won't burn up this circuit because they don't draw too much amperage. The one board that David has and the one board that I have, these are both boards that we use for testing and nothing else, and they were given to us. Someone's fix for when the GI burnt up was to put this big ugly wire mess of poo on here. And well,
it's replacing this header here, which had burnt. It was black, it was charred, it was a mess.
It's a valid operator fix. It's not a valid fix for the home end user or a collector, because it just doesn't work right. And we recently had someone say to us, it was another technician, someone had done this to a board that he was repairing, and when he replaced it with a brand new $400 board, they wanted him to remove the header and put that piece of crap in there on a brand new $400 board. It's just wrong. So one of the biggest problems is in the WPC was that when you're designing a pinball machine and you get to the end of the project and the money's short, everybody goes, where can we start cutting costs so that we can get this to production, to get this out to everybody who wants it? And one of the first things they say is, oh, well, gee, we don't need all this wiring here, and we can save tens of thousands of dollars by using insulation displacement connectors. An insulation displacement connector is kind of like a V shape.
Yeah.
You stick the wire into it and you punch it in, right? So you're only just cutting an edge and making contact with that wire. It's very ineffective. And
it's effective at first.
Yes.
While it's still tight, while the whole 18 strands are in there. The problem is you've just put it into a vise of a pair of scissors. And your machine moves, your machine plays, time, you cut one strand, you cut two strands, eventually you cut most of the strands, and instead of having 18-stranded wire, you got 4-stranded wire trying to haul the same amount of current through it.
And that
physics
amperage
says no.
Yeah. and that amperage starts to climb, and that's where they start to roast.
As the current consumption goes up, it generates heat. It becomes like, you've seen an incandescent bulb, they get hot. Well, it's the current consumption goes up, heat goes up. With the heat going up causes it to be an increase in resistance. The higher the resistance, the higher the current consumption, you have a feedback loop, and it will just get so hot. These white headers will be brown, they will be black, they will be melted.
Some of them actually become desoldered and fall off the board.
Another problem with those insulation displacements is that the pin is this square, and the wiper of their contact is this curved metal piece. It's curved so it goes down easily onto there. But you have this little tiny contact patch. When we rebuild these, we changed them from the insulation displacement to a crimped on pin, which is now gripping the entirety of the stranded wires and the insulation. And we use what's known as a trifuricon pin.
Show that trifuricon pin, David.
Yeah, this is going to
be... The unique thing about the trifuricon pin is when we replace a header, the new headers are square.
You can actually see that there's 3 contact patches that are actually going to be touching the pin. So now instead of it just being this one little bit, it's this. You've got hundreds of times more contact patch. You've got much lower resistance, so your current isn't going to be causing you to have this heat feedback loop. When we rebuild one of these, it's a permanent fix. Unless you've got something really stupid.
One of the interesting things that they did, and because you can do this very easily with insulation displacement connectors, is they took where they originally had designed 2 18 gauge or 16 gauge wires to run up to 2 circuits. Well, what they did, it's insulation displacement. They said, okay, we'll take one wire, run it up, and loop it over.
Into the other one.
Into the other one, and we just saved 6 feet of wire.
Which is 14 cents times 1,000 machines. It's now 140 bucks, and then we care. Well,
and
we don't care.
That's
they did.
Why they did it. It was a cost-saving measure, and at the time that they did it, it wasn't 14 cents. It was probably maybe $1 because it was expensive then. Now it's like David says, it's 14 cents. What we did when we found this problem is we went back to the schematic in the WPC schematic. And at first I made the mistake of I used a WPC 89. The WPC 89, the GI, had 10 different colors in there. And oddly, I had all 10 different colors of wiring, and I made it and I went, that doesn't seem right. And so I went to a WPC S or a WPC DCS, and I looked at it again and I went, this is exactly the same, but what they did is they used 2 colors, just like they did in the System 11s and before, and those 2 colors were exactly the same as they were before, which was yellow and white yellow.
White with yellow stripe.
And which, as far as GI goes, it makes sense. And then they used a center tap, and they called it green. And so, thus, I built that with green. And it doesn't matter what colors you use. And at first I thought in the WPC 89s, the reason they used different colors is they were trying to identify this is circuit number 1, this is circuit number 2, 3, blah, blah, blah. And they correspond, those circuits actually correspond to these triacs. So one of these triacs is circuit number 1, one is 2, 3, etc. You can chase it from the pins, and it's In the scat, it comes from the pin to the triac. There's no reason for the different colors. And so I went with, it should be the yellow-white, the white-yellow, with the one green. And that one green is your center tap ground.
And it's just a ground. It's giving a well-known center point so that all the entire machine's running at the same ground plane.
So the first thing that's going to happen is these three headers, which are going to be J115, that is the input header, and then J120 and 121. The difference between 120 and 121, one of them goes to the head, the other one goes to the playfield.
So there's your input.
Those are your outputs.
These are your outputs. The interesting thing about the outputs, you'll note they both have the same key pin, and they are jumpered straight across on the back. If you swap these, you didn't do anything wrong, other than making your wires a little tight.
So the 120 and the 121 are totally interchangeable. It really doesn't matter, and it's exactly like David says. On the back, they're jumpered together. No big deal. Those are jumpered with a nice thick foil trace, and usually pretty good to go. A lot of times what you'll see people do when they try and repair the GI in a WPC is they will replace the header and the header only. That fix is good for approximately anywhere from 3 hours to 3 weeks. Anything after
you've still got
junk.
That little problem, that tiny contact patch. Oh, another thing with that, as the resistance goes up, the heat goes up, that pin, it loses its tension, which makes it sloppy, which increases the resistance, which causes more heat, blah, blah, blah. Which is why changing the header out just means you change the header, that you're going to be changing again in a little while, because it's going to get hot and it's going to get burned, because you didn't fix the other side. Now, if you change just this side, you didn't help your burnt header.
That was funny, because people will tell me, I changed that connector out. I said, your connector's all burnt. You see that, right? Well, I just changed that 3 days ago. Yeah. You didn't change the header, did you? The header.
Change the header? Why would I do that?
Why would I do that?
It looked fine. Did you notice that it was kind of goldish color? Yeah, that's called heat checking. That's called it's lost. It's screwed. Just replace the damn thing.
So,
the biggest scary part about these is they are big, heavy traces. They're going to be a little tricky to desolder well. If you don't have a nice, powerful soldering iron or a desoldering gun, they're going to be a little challenging. If you don't do it carefully, you can pull stuff. But you just be careful, take your time, and you can get it done. But you have to do it.
the old ones were actually 1.5 millimeter, and the new ones, the new headers, I should say, the new black ones, which are better, are 1.6 millimeters. So they're just a hair larger. And the Hakko USA, H-A-K-K-O, they make desoldering tools, they make soldering tools. They have a drill bit cleaning tool for the desoldering gun at 1.6 millimeter. That drill bit is on a, what do you call that?
Jeweler's.
A jeweler's type drill bit thing. You know, it's about 8 inches long, and it's it runs about $15. When I take one of these headers out, I run that drill bit through there, and the reason I run it through there is it does not damage the via, if there is one. It does not rip the trace off when you go to put it through, and it makes for a better hole. And when you put your header in, it just goes in real nice and smooth, and it doesn't, you know, especially does not tear up traces, and or any of the rings or anything like that. It's a very, I think it's a very good idea. I like it, and it creates for a good final joint. So what we've
Talk
done.
about my jump rope?
Huh?
Talk about my jump rope?
Yeah, let's talk about David's jump rope. So what we did is, when we started looking at this and going, geez, these are all burnt up like this, and we got these two gems here, and I went back to the scat and I said, well, this is supposed to have 2 lines. Well, what would happen if we put the 2 lines at the transformer end instead of looping it around? We put the 2 lines at the transformer end, and the tension is perfectly fine down at the transformer end. So now we're passing that same voltage and amperage up 2 lines to the board the way it was originally designed.
On 2 sides.
Which cuts the heat in half and cuts the chances, if you're using incandescent bulbs, of burning that circuit up again in half. And we've started going to, for at minimum GI, we've started going to LEDs. If we put this correction in there, it'll never, ever fail again. And these boards, these WPC boards, there are aftermarket boards. They're starting to get few and far between because Rotten Dog is starting to get out of making them. They've already quit making the WPC 95. Those things are like gold. We saw one on eBay go for $3,200 because they are rare. And if it's burnt up, it's junk. The regular ones, the non-WPC 95s, go for $389, I think it is, plus tax, shipping, license, everybody else's share. So you're into it over $400. That's kind of a tough pill to swallow, for something that, this to make this harness, to replace this, and the headers and the connectors. Me personally, I'm into it less than $5.
Now, he does this on a regular basis, so he does get some economies of scale.
I am an exception. I do have volume in wire. I do have volume in pins. I do have volume in connectors. Okay, so I am an exception. The average Joe pinball player could do it for themselves with shipping for less than $30. Guarantee it. I could give you the contacts, less than $30, and that's without,
assuming you have the tools.
Without me selling you any parts.
The tools do cost a bit more, but having the tools is always good.
With using trifurcon connectors, we're going to have David put the last one on, and I left that so you can see how easy this is. A lot of people use the Waldom HT, I can't even remember the number, 1805 or whatever the hell it is, and
it works.
It's an okay crimper. It's just not that good. This is a Platinum 16801C Charlie open barrel crimper. The difference between an open barrel crimper and the Waldom is that the open barrel will do both sides at the same time. It will do the side that has the contact with the wire. It will also do the side that has the contact with the insulating jacket on the wire.
There's the insulation, there's the actual wire portion.
And this is why I wanted David to do one under camera, so you can see that this is one action. But to make this tight going into the Molex connector, I always like to do a double action because it has 2 different sizes. The larger size is for the .156, the smaller size is for the .100. Your .100s are usually found on your CPU down at the bottom here, or it's also can be found.
All these are 156s, these are 100s. It's the size of the pin, 0.100th of an inch,
Yeah.
0.156 of an inch.
So with a .100, there's actually 10 pins to an inch. With a .156, there's 7 pins to an inch. That's how you tell the difference. So these guys are wonderful. You can find them on Amazon. They run about $20, $25 for a pair shipped. The only thing is these are a right-handed tool, so if you're left-handed, you're kind of screwed. I have a very good friend that is a technician that's left-handed, and oh my God, he cannot use these to save his ass.
All right, let's see if we can do this on camera. Got your wire, got your pin, putting it on. So you've got the insulation going to be gripped by the larger part. You can see from the side it's a little bit larger, it'll go around. You have the stripped portion. Now, one thing that's important is the amount of strip. If you stripped out 1/2 inch of wire, you're going to have a bunch sticking up under the actual contact. You don't want that. You don't want a whole lot past what's going to crimp. So
the approximate strip length is approximately 1/8 of an inch.
Which is just about the thickness of your stripper. So
Yes.
when you go to strip it, you're going to look, okay, you want about the thickness of that sticking off. So when you strip it off, that's about how much you end up with. All right, now this is where having a touch of a fingernail comes in handy for me, because I can kind of hold it by fingernails. Then I'm going to slip it in. In this case, we're going to use the larger size. Getting it in there, square, and then just close. Now at this point, everything is being held. Squeeze it all the way, and we have connection. Now, you can see that this isn't exactly as nice as we'd like. So this is where you can come up, you can choke up. Oh, one thing that's interesting about these is you can actually see there's a die on here. There's a little bit of difference in the actual pattern that it's going to crimp. So it crimped the inner tighter than it did the outer because it knows insulation. So we choke it up to use the actual wire portion of crimp, give it another squeeze. Now we've got a nice real tight grip on the insulation. At this point, you could grab, you could pull, you could use pliers and try to pull that off of there. It's not coming off, which is the whole point of the crimp. It's mechanically tight. It's also gas tight in the crimp area, so you don't get oxidation causing resistance and the whole heat loop again.
Being gas tight, there will be no corrosion underneath it, and that is the goal of being gas tight.
Back in the day when I was a neophyte, I would then go, oh, well, I'm going to be putting a lot of power in here. I'm going to make it better. I'm going to solder that too. Okay, you don't need to do that. I've stopped doing that.
Anybody that solders trifurcon pins is wasting their time.
The biggest problem with that is you can guarantee you're going to end up melting insulation, making this a bad crimp, and now you've got a weakness point.
Also,
it makes sense.
9 times out of 10, when they solder and that shielding comes back, now you have an exposed area that will corrode.
Yeah. So then the pin, the header, there's a little tab on the back of the pin that is going to actually go into the slot on the header, and that's what locks it into place. If you try to put it in backwards, it's not going to fit right. You can jam it in there, it's going to jam, you're going to end up cutting and pulling this apart and to replace it. But if it goes in right, it just slips in and there'll be a little click. Now that's in there. That little tab is now in the slot, it's locked in place, everything's good. Rinse, repeat for all your other wires.
So if you go ahead and stuff that, then we can actually put it onto, pick one, and well, it'll be this one because the other one is jacked up, but and then we can do a tug test on it and show you exactly how much tighter the trifurcon pin Molex connector is than an IDC connector. When you're making contact on a square pin on 3 sides, vice weakly making it on 2 sides, it's a lot tighter. Of course, you shouldn't be having to constantly pull those on and off but that's where you're going to run into, oh God, this kind of sucks because, oh, I got to keep taking this board out. Well, you shouldn't have to if you've got a
couple of features of these. This is a locking ramp that goes there's a little bit of a nub on these. Actually, this one doesn't really have it. The black one does.
The design for locking ramps was also to ensure that your connector didn't back off your header.
Yeah.
And
on these, you can see there's a bit of a, it's a little hard to see in the camera, but there's a little bit of a ramp there. So when you insert this onto there, that was not trimmed. Doc, you keyed it for that one. That's what's going on.
What?
It's keyed for the other one. It's the input.
It's keyed for this one.
Yeah.
Yeah, I didn't have a choice.
I figured it out. So when you put it on, it's going to push past the pins and give you a very positive connection. Now, as I was discussing keying pin, this is missing a pin. They did that at the factory. They decided it's actually indicated on the board. Everywhere there's a key pin, there's a little triangle showing you that is going to be a missing pin.
However, on WPCs and System 11s, they did something silly, and that is up here on the secondary. They took a 6-pin and a 2-pin. And yes, the 6-pin is keyed, the 2-pin is not, and they go together like one single 8-pin. Or actually, it's a 9-pin. And you can make the mistake of, okay, I put the 6-pin on, these are empty, where does this other 2 go? If you put it on this guy up here, it'll smoke stuff. All the way down to the transformer.
Yep.
And,
your wires get charred. You smell the melt, and you're replacing wires all the way back.
Hey, but those are blue and white and blue, and I have those colors, so it's all good. And,
So when you build the connector, it comes with all these open, but they sell key pin plugs. Put it in where it's supposed to be. So if you're doing it with your eyes closed or in the dark of a back box, you can't get it off.
When you're looking for keying pins, they're actually referred to in the industry to search for them. They're called polarizing keys, and they come in different sizes. But
you need to use the right size for the connectors you're building.
These are .156 polarizing keys. I think they've gone up in price. I think they're a dime. They used to be 6 cents.
Don't buy just one of anything like that.
You know, they're
buy 100.
Yeah, they actually cost about 3 times as much as trifurcon pins. You know, trifurcon pins, even without buying them in bulk quantity, I can get them down to about 3 cents a piece, which is kind of nice. So the next thing is this other connector that we put on this end, this rectangular connector, is already in your game. It's down at the transformer. It comes about a foot off the transformer. It's a .093 Molex connector with, I believe it's male pins, isn't it?
This is male pins, yes.
Male pins. It's a male connector with male pins. And there's no way that we could show you, but on the back of it, where the wires go in, it's actually numbered.
Yeah, but nobody can ever read the damn thing without the light. So just the right angle, and
of course, I'm old and I'm blind, and well, he's blind too. So we use magnifying lamps.
Harbor Freight, $20 disc.
They're awesome.
I got 6 of them because every bench.
And of course, we've got them at the command central station. And you know, it's very helpful in identifying cold solder joints. It's very helpful in identifying chips where you can't read the numbers because, well, I'm blind and I can't read stuff this big. And also, it will help you tell you what pin is what. But the nice thing about the WPC, even in the WPC 89s where they used 11 different colors of wires. At the transformer side, it's white, yellow, and yellow, white. They didn't use the 11 different colors on that side, which that's why it became silly to me. You know, I was like, wait a minute. This side, all the there's 11 colors, and it's yellow, white, white, yellow, white, yellow.
So you'll need roughly 6 foot of wire. That'll get you from your back box down through the head hole, straight under to your transformer.
That will fit inside the what do you want to call it? Cable tube, the plastic sheathing.
Yeah, the split loom tube. You can feed it through there. You have to cut a bunch of wire ties, strip out the old wire, because a wire not connected to something is a guaranteed nightmare for the next tech who's going, what the? Why? No, wires always should be connected. Well, yeah, if it's a dead wire that you pull it out.
4-inch zip ties can be
purchased,
bought by the thousand for right around $20 a thousand. And you know, it seems like 1,000's a lot, right? No. In a wire like that, you want to put it every 3 inches. And the way I do it to every 3 inches, 3 inches is correct. Yeah. So if you, of course, now I got these big monster hands, mind you. But if you go 3 fingers, that's your distance. You start there, put one there, 3 inches, and continue on all the way down the line. And that will pretty much mate up all the way down, and life is good. Pick it up. I lost train of thought. Yeah.
To get the old one out, now I'm a little more lazy. I'm not likely to actually go through and strip all the zip ties and rerun this through that. I'm going to run it in parallel. I'm going to cut the old connector off, and there's enough slack in the zip ties that are the factory zip ties that you can pull one, and then when you pull the next, the rest of them just come out. And I'm going to pull them all the way back out. I'm going to pull the entire old line out, and I'm going to take that, and I'm going to throw that wire chunk in a box as scrap wire. There's a lot of wire there.
It's still good. You're still going to get a good 5 feet of wire out of it. Easy.
Unless this is melted back to here, which is telling you this wire has gotten really hot. It's going to have actually burnt the wire all the way back, in that if you were to strip it off, the wire is going to be oxidized. It's going to have reacted with the insulation. That is going in the trash can.
Yep.
I'm not
that you can usually feel, because it feels kind of crunchy when you.
If it's not pliable and flexible and sexy, it's junked. Old wire does get bad if it's been overstressed.
Oh, I remember where I was going now. We were 6 feet is what you need. We measured 3 different WPCs, and they were different generations. And initially, we had thought, David took a measurement and thought that 7 feet was correct for one specific one that we were doing. And I said, are you sure? And of course, Williams doesn't tell you the length of any wires anywhere. None of the manufacturers do. And which, if you have to replace wiring like this, it kind of sucks. And
well, they wanted to sell you a harness if they had to.
You know, and so I did what he asked. You know, I made it 7 feet long, and
actually you made it 8 foot long just in case it was our first one.
Yeah.
So we'll try it, and then we got that big.
We had 2 feet too much, and we ended up coiling it. But still, yeah. You know, we went to the 6 feet, and it still gives you some excess play in case you ever have a problem again, which ain't gonna happen. So, you know, it's totally your call. If you want to make it, you know, measure it dead up nuts on, give yourself at least 4 to 6 inches in case there's a problem in the future.
Yeah, Williams.
And you're probably looking at
they've measured their stuff out to the 1/4 of an inch.
Yeah.
Because a 1/4 of an inch of wire, when you're doing thousands of machines, adds up. if I were doing thousands of machines, I might care too. Yeah, no.
So we do also, if I can find one, brown. Okay, straight replacement headers. These straight replacement headers are starting to become they are obsolete, and they're starting to disappear. They come in a 24 position 0.156 breakaway, which means you count however many positions you need and then you break it away. They used to be 48 cents for 124 position. They are now $3. And that's buying them in bulk. They're $3. If you want onesies and twosies, they could be as much as $5 each. And if you want to show that under the camera, how nice and square that is with the nicer ramp than the white ones. The ramp is actually a lot tighter and will give you a better hold when you put your Molex connector into it. And if you're...
Well, I can't get it on there because of the keying pin, but I can do this side.
And if you're still doing the half-ass job and not changing it out and using your IDC connector, it'll still give you a better connection to the IDC ramp.
Yeah. These are plated. They're tin plated. You can get them in gold plated. Don't bother.
It's almost to the point where the gold plated are almost cheaper than the tin plated.
Because nobody's using them.
Because nobody wants to pay the money for them.
If you are getting gold plated, get gold plated trifuricons. You want to use the same plating for both sides.
That is a fact. One of the other reasons that David doesn't like to use as many zip ties as I do, it's not because he's cheap, it's because it's a pain in the ass to get them tight. And I have one of the parts suppliers gave me a zip tie gun, which are about $8. And that tightens them for me. And I was like, hey, I like this, and and so I don't have to tighten them. I just put them on, and as long as I get them remotely close, zip, 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 zip. And he has to physically tighten them and then cut them. That's the difference. And when
well, I also I'm morally opposed to zip ties because my wife makes me use them in places that I think they're stupid.
Well, they weren't meant to be a belt.
Or a prophylactic.
So that's pretty much the nuts and bolts and wires, so to speak, of how to save the GI on, one that's not roached. The other portion that I did want to cover that recently happened was I had another repair tech contact me and say, we've got this, and I don't remember which version it was. It may have been a 95, it may have been an S. I don't even remember the game. And what their problem was that their GI was not working correctly. And of course, the first thing I said was, what do your headers and connectors look like? And they said, oh, they're perfect. And I was like, yeah, okay, let me look. And I came over to their shop and I took a look, and they were right. They were perfect. And their GI wasn't working. Well, these 5 triacs are not the only thing that controls the GI on these. There are 2, in most WPCs, there are 2 ULN 2803 alphas. The ULN 2803 alpha is normally used in the switch matrix right underneath the battery pack on the WPC CPU. And it works in the same manner for the GI lighting. When the ULN 2803 alpha fails, you lose control of the triacs, and they do weird things. And I believe one of them is right here, and there's another one similar to it, right? It's in there somewhere.
Yeah.
So there's 2 ULN 2803 alphas, and I believe there's 2 LM339s that have to do with your GI and your triac control. These other techs are pretty awesome techs, and they had looked completely through the scat and didn't see it. And it's just something that I know is there. And it took me a while to find it, and I was like, oh, here it is. And I'm looking through it through a big magnifying lamp and, you know, big sheets like this. Oh, yeah, it's here. It's this. I guarantee it's this. Well, can we test it? I said, nope. Grab a couple chips, pick it. It's either this one or this one. Can't tell you which. Replace them. You know, and I said, hey, socket them both. Whatever. They replaced them, and they're like, God, we've been fighting this for 3 weeks. Can't find it, can't find it, can't find it. There it is. That simple. But that's just something that I've encountered before, and so I was able to help them go, hey, I've seen that. Nah, that's no big deal. I just need to show you where it's at, and I can't find it here. It's there. So.
Any questions? Anybody awake?
All right.
Oh, somebody's awake. Yay.
Outstanding.
Kind of maybe somewhat off topic. When people say they lose 5 volts and the driver board's got to get rebuilt, what exactly is rebuilt?
Okay.
I don't want to go too crazy.
No. Here's check this out. This is simple. So these things have a known design flaw in the 5-volt system, and it's very common. The first thing that you want to check to verify is that BR2 is good, and or the traces to BR2, bridge rectifier number 2 here on the top. The next thing that you want to verify is whichever one of these 2 caps connects up to BR2.
So the comment about are the traces good? Well, they're top traces. They can be a little hard to see. It's not uncommon to see these jumper wires because those traces aren't good.
But generally speaking, if it's constantly resetting, remove C4, cap C4, and replace it with a 220 ohm, 16 volt or larger. So 220, 16, 220, 25, 220, 50, whatever, cap, and that should cure your resetting issue. They put a cap in here that as it degrades, it causes resetting, constant resetting. Some people will take a cap and just, this one right here, the C4, that little guy right underneath the fuses. I think it's a, what is that, David?
On this one, it is a
100. Yeah,
it's
little tiny guy. It's this little gray guy right underneath the fuses.
I thought you pointed to it.
Yeah, that guy right there,
Yeah.
C4, little teeny tiny guy.
Yeah.
And the problem is that particular cap, when it degrades, it causes resets. And you know, the average shelf life on one of those caps is 5 to 7 years. The service life is,
well, depends on how badly it's been out of spec.
you know, he's more of the service life, shelf life kind of guy than I am. But you know, the shelf life is 5 to 7 years. We know these things are 20 to 25 years old. So they're at the point where those caps are going to start failing.
Why is it temperature sensitive?
Temperature sensitivity affects the resistance of the capacitor. So these are electrolytic capacitors. It means that there's a coil of paper dipped in goop, and that goop dries out. As the temperature changes, it will cause that to dry out quicker, or it will affect what's left of it in there. So you get temperature sensitivity when those start to degrade. The capacitance goes down, the resistance goes up, it makes the circuit behave. In a lot of cases, capacitors like these are being used as filter capacitors. They're there to stabilize the power input. Those really don't matter if you had the exact same rating, as long as your voltage isn't lower. If you put higher capacitance, it wouldn't be a big deal. Now, this is actually being used in effectively a timing circuit to bring the machine up. The reset has to be nice stable, but they want to do it after they're positive, all the power is good. Timing specific capacitors, you need to make sure they're the same value because it affects the timing rate. A capacitor charges at in a known path, it gets to the peak at a certain point, a known time, and it'll discharge in a known way. When they deteriorate, that curvature changes, it becomes different, and the circuit just doesn't work the way it's supposed to. You can't just throw anything in a timing specific place. You want to use the exact same value just to keep that designed timing the same. You can get away with tacking something on there to see, oh, did that fix my reset problem? But you still might be a little flaky. Replacing it with the correct part is going to solidify it.
You know, if you're actually curious about it, you can take a 220/50 and use alligator clips and clip it to that capacitor, as long as you maintain the polarity of it.
Yeah, we've got one on the floor that we're experimenting with this weekend. It wouldn't boot consistently.
We just soldered it right on top.
And,
it's booted,
wow,
it's booted perfect ever since.
Ever since. Now, we'll want to change that to the proper part.
Yeah.
It's an experiment to
And
prove out a
these-
theory.
I don't remember the value of these, but I'm pretty sure they were 116s.
It's underneath.
So 100 microfarads, 16 volt. And the other problem is that axial caps are beyond obsolete, and trying to find axial caps they're expensive. It's you're paying like $4 for one of those.
Axial meaning the leads go through the axis of the cap.
I can get a radial cap of that value for like 6 cents. 10
Radial
cents.
caps have the legs sticking out,
Both legs come
on
out
the same side.
Same side.
Depending on the size of the cap, maybe 3 legs for stability.
But that's where your 5-volt power issues lie. And there's been a couple of people that have made these 5-volt
Reset replacement.
Yeah, and you really don't need that. You need to understand how the circuit works. And a lot of times, you see this metal heat sink is pretty good chunk of size. Well, that's because these bridges get hot. And a lot of times when people replace these bridges, because they do fail.
This being discolored, not an uncommon problem. That doesn't mean it's bad. It just means that things have gotten hot.
They have a tendency to either tear up the traces when pulling them out, or they don't get enough solder to flow through to make contact on the trace on the upper side as they do on the bottom side.
And in this portion of the circuit, it's important that both sides are being soldered well.
Yeah. And sometimes the trace on the top side does fail. I mean, it just the foil just says, I'm done.
The heat caused basically the epoxy that was used to keep the copper plane on the fiberglass to just fail.
Okay, so is there anything else that we can answer for you today? Outstanding.
His underwear color is white. Don't ask me how I know that.
You are so wrong, brother. So wrong. Anyway,
Brown doesn't count.
dude, we won't talk about when the doctor asked you for a specimen and you gave him one of each with your shorts.
No, that was my sock.
Okay. I don't want to know about your duty sock. Thank you all for coming. We appreciate you being here. Game on.